we're going to factor this polynomial completely. We're doing this a lot. It's good practice, good practice. And the thing that stands out to me here is the idea of grouping. Because, let's see, what can I take out of both of these? I can take a 3 out of both these first two. So I'm going to take a 3, and also I can take an a squared out. They both have at least an a squared. So that leaves behind a 12 and an a. And that leaves also a 5 for that one. A squared's gone. And then let's see, over here, what can I take out of both of those? A 7. I can take a 7 out of both those. So let's see. They both have 7 as a factor. It was 12 times 7 is 84. I still have an A. And 7 out of 35 is 5. So at this point we see, oh look, it's the same thing. So that's one of our factors, 12A minus 5. And then, let's see, we'll do this one. We have the leftovers, 3a squared plus 7. And we look at that, we kind of look at that sideways, and we say, hey, a squared, maybe I can factor that some more. But then I see this plus sign, and I see that there's no middle term. It's just a, and it goes right to 7. There's no like 2a in the middle or something. So I'm thinking, yeah, the adding really killed it for me, but the fact that there's no middle term and it's adding, I'm not going to be able to factor that. I mean, you can verify that with your ACB and all that kind of stuff, but we're barking up the wrong tree there. We were a lot more excited if it was negative and these were perfect squares. Well, this isn't a perfect square either, nor is that. So, and it's not negative. So anyway, this is all wrong. So we're done, and we think to ourselves, well, when is a going to give me a 0 here? Now, I haven't always been doing this, but this is one thing you can always do. Instead of saying, I don't want 12, I'll put it on the bottom. I do want 5, I put it on the top. You can just set it equal to 0, and you can solve for a. You can always do this. I've just been kind of skipping over this, but I want to review this idea with you again because it might be a useful idea. So that means that a is equal to 5 over 7. And that takes care of our sign and everything. It's a positive 5 over 12. Did I say 7? 5 over 12. And you know what happens. Look up here. If I have this 12 over a, and I multiply, the a by 12, well, the 12 is going to cancel. I'm going to get 5. 5 take away 5. Well, you can see where I'm going there. So, oops, too far. All right, so there's one of mine. And then how can I make that negative? And because I need it to be a negative 7. When does 3a squared equal negative 7? Because I need it to go with the positive 7, right? Well, this doesn't happen. Ever. I don't care what you put in there for a. That does not give me a root. So I get one root this time. There it is. There's my one. Well, I factored it. I guess I was just supposed to factor it. I went a little further, but it illustrates the fact that sometimes I don't get 3 roots. Sometimes I get less. And we'll go into that a little bit more. I mean, I think you know already about the fact that some of the roots are imaginary. And if you don't, now you've had a hint about it.